Hi guys, Mr. Hill here with your science lesson for today. We're going to carry on looking at materials and their properties, and today we're going to look at a particular property of water absorbency. Now, our last lesson, we didn't want that to happen. This lesson, we are going to think about it. So we need to know what absorbency means. We need to be able to make predictions using our existing knowledge. So we need to think about what we've already done. What experiments we've done where we've found things that water would be absorbed by or what would be water resistant. We're going to investigate materials to find out how absorbent they are. So a recap. What properties should a material have to make a good umbrella? Pause the video here, have a think. Can you write me a list of the properties that you can remember from last time? How did you get on with your list? The first thing and the most obvious thing for me is water resistant. An umbrella is not going to be any good if it lets the water through. So it needs to be non-porous. It needs to be flexible as well. If you think about when you fold an umbrella up, it all folds up nice and neat into a small package. It wouldn't be very good if your umbrella had to stay open all the time. You'd never get it in through the front door. Also needs to be strong. So it's no good if it starts raining really heavily, if that rain manages to make holes in the umbrella, because it won't be an umbrella anymore. It'll be more like a colander, which when you're trying to stay dry is not going to work terribly well. So if a material does not let liquid in, we call it water resistant. But what if it does let liquid in? In fact, what if a liquid soaks right into the material? What do we call these types of material? Have a think for a moment. So think back to what the beginning of this lesson we were talking about. We're talking about water absorbency. So we've all done it. We've knocked over a drink and we need something to mop up the mess. The material we choose needs to be absorbent. Otherwise, all we're going to do is push the mess around, either the tabletop or on the floor. We're not going to clean it up. So today's problem, we need to find out which material is the most absorbent. We're going to look at the write-up of an investigation and see if you can follow the directions and create your own set of results. So this is why writing our method is really, really important. So we practice writing methods in order to have the method so we can test it ourselves. So this time, instead of you writing up the method for someone else to test, we've got a method for you. You're going to follow it and you're going to produce your own set of results from your own sample of materials. So our question, from my sample, which material absorbs the most water? Now, I wonder if you can remember, why do we use the phrase from my sample? Take a moment, have a think. Can you remember? It might be a few lessons back that we discussed this before. The reason is, but our sample was, we haven't got a piece of everything. So we can't ask the question, which material absorbs the most water, because the number of materials in the world, we don't have space big enough to test all of them or the time in our lessons. So we're going to have a sample of materials. The prediction, I think that this material will absorb the most water. I think this because, and give your reasons. It's all well and good just being able to say, I think piece of cloth A will be the most absorbent. What makes you think that? So we've got a diagram. This is how, if we were in school in a perfect scenario, we'd set it up. We'd have an angle clamp, we'd have our rod, and we'd have our different materials hung over the side. We're going to have to do it slightly different because we're at home. So our method. First, collect a selection of different materials. Please don't go ripping chunks out of the sofa, out of your clothes, or anything else that anyone else might need or want. So check first with your parents, Don't damage anything important. Secondly, cut them all to the same size to keep the test fair. This again is why you check before you start hacking away and cutting things up. Now, the third step, stick the ends to a wooden spoon or similar and suspend them across 2 cups or similar so the ends of them each material nearly touch the ground. Place a tray of water under the materials with their ends in the water. You might want to put some food colouring in the water to make it easier to see as it goes up the material, but this isn't a necessary step. It's a nice thing to be able to do. If you haven't got food colouring, don't worry. Leave the experiment for 5 minutes, then measure how far the water has climbed up the materials. So this is how we set it up. We have our wooden spoon across 2 cups. We have a small tray with some water in it, which has got some colour. Note this one hasn't got food colouring in it. And you can see that some of the materials, so if you look at the one on the left, the water's soaking up it, and the one on the right, the water's soaking up it as well. This is an idea of how you could set your test up. So the results. After the 5 minutes, you're going to take everything out of the water and you're going to measure how far up the water got. And then onto Tapestry, place a photograph of your experiment together with a table of your results to show us which material you found was the most absorbent and would have been the best for the job. You will also need a conclusion. So with that, I found that, and you're going to put the material that absorbed the most water in. Then you're going to use the sentence, this shows that my prediction was, and then you're either going to be correct or incorrect. So make sure you follow those sentences that we've put up and use them in your write-up. So a final thing for you to think about. Where is it that we need absorbency for water? Now, this baby just did a number 1, but I'm still dry. So we're talking about babies, and of course we're talking about nappies. They need to be absorbent, but they don't want to get overly absorbed with water. So this baby also did a number 1, but it's not dry. This one's dry, but I think its nappy isn't comfortable. So what properties would make the best nappy for a baby? Have a think about this and add it to the bottom of your experiment. So it might be really useful. Our sponge is really absorbent, but would it necessarily be comfortable sat against your skin? So lots of effort and lots of money goes into researching the best materials to use for making nappies. So can you think of the properties that you can think of that would make the best nappy for a baby? I'll look forward to seeing your work on Tapestry. I'll look forward to seeing your experiments and your results. Good luck, stay safe, and I'll see you again very soon.